All right, so if you look on the board, you will see today's learning objective, and I'm going to go over them really quickly once I find my paper that I should be well organized in. Okay, here we go. All right, so our learning intention for today's lesson. Students, add integers by counting up and negative integers. Add positive integers, by counting up, and negative integers by counting down, using curved arrows and a number line. We'll get into how that looks. Students play an integer game by to combine integers, justifying the integer plus its opposite added to 0. That is the one thing that we're not going to do, but I did want to still mention it. Students know the opposite of a number is called the additive inverse because of the sum of the two numbers is 0. So let's get into the first part. So your first part says, exercise 1, positive and negative number review. It says with the partner, but due to COVID, we're going to have imaginary partners. So we're going to pretend like we have a partner next to us. And we're going to use the graphic organizer down here below, the circles, to record what we know about positive and negative numbers. That is the first thing we're going to do. And it should only take you about 2 minutes. Okay, so you're going to add statements telling me, what do you already know about negative numbers? What do you already know about positive numbers? And what do you know about both of them? So take about 2 minutes to go ahead and start writing what you already know about negative numbers and what you already know about positive numbers. Do that now. All right, so now let's go into our negative circle. I'm going to ask you to raise your hand today, so give me some examples. What do we know about negative numbers? Somebody give me something. Yes?
They're the numbers before 0.
Huh?
They're the numbers before 0.
So they are to the left of 0, located on the left of 0. And if for some reason you don't have these answers, write them. That's fine. Give me something else we know about negative numbers. Yes. Okay, less. So we say they're less, which means they decrease as they get bigger. It is less. How do they look?
They got a dash.
They have a negative sign in front of them. And they are the opposite of what? Opposite of positive numbers. All right, what about the positive numbers? What do we know about them? They're located on the right. Located on the right of 0. What else do we know? Okay, no sign. What else do we know about positive numbers? Huh? Opposite of negative numbers. That is correct. And what's the last thing we know? That they do what? Increase. I'm sorry, somebody said it. And I apologize. I did ask you guys to raise your hands. And they increase. Now, what do we know about both of them? That is true. But what do they both have in common? What do they both have in common? Where are they both located? Where can you find both of these? Huh?
Behind the 0 or from the 0.
On a, I can't hear you. On a number line. They both. They both are located on a number line. So that you can see it. Okay, I'll say it. They both are located on a number line. So if we go to the next page, like I said, this lesson is fairly easy. So we shouldn't have any problems with this lesson. Either you're in person or at home. Okay. It says, counting up and counting down on the left number line, on the number line. All right, it says use a number line below to practice. There's a number line right there below. I'm going to draw one up here just because. Number line 0 is always in the middle, and I'm just going to go to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Now let's look. It says, counting up starts at 0, corresponds to what numbers? If we're starting here and we're counting up, it starts positive. Please write positive. All right, counting down, starting at 0. Negative corresponds to negative numbers. Please write negative. Now I'm just going to tell you, a negative 7, we're just listening. A negative 7 is 7 units to the left of 0. So what that looks like is, if I were to say this right here. First of all, do we know what these two lines mean? No. Those two lines mean the absolute value of negative 7. And anytime you see these lines on any number, it means absolute value. And I'm going to tell you, the absolute value is from negative 7, how long does it take us to get to, how many jumps will it take us to get to 0? 7. So that means the absolute value of any number is always going to be positive. Can we see that? If I had negative 8, it's still going to take me 8 to get back to 0. This is called the absolute value. And the absolute value of any number is always going to be a positive number. It'll never be a negative number. Okay? Because it's how many jumps can we get back to 0. So if I were to say positive 7 is 7 units to the right of 0, I'm going to take the absolute value of 7, and it's still going to be 7. If I come here to 7, how many times do I jump to get to 0? 7. Again, I say this answer would never be negative. Never. The absolute value of a number is negative, never negative. All right, so now let's look at the question A. Where do we begin when we locate a number on the number line? 0, write it. Start at 0. Yep. What do we call the distance between, now let's see who's listening. What do we call the distance, thank you, between a number 0 on a number line? Between a number and 0 on the number line, yes. Absolute value, correct. And if we don't know how to write it, I will write it for you. A, B. Absolute value. What is the relationship between 7 and -7? Yes. Are you stretching? What is the relationship between the 7 and the -7? They do. Well, what is the relationship between them? 7 and the -7.
They're both.
Yes, they both have the same distance. Okay, so they are both the same distance from 0. All right, so now, looking at example 3, it says using the integer game on the number line. Again, we're not doing the game because, well, for one, I don't have the cards printed out, but it's okay. We could pretend as if we're doing the game. What is the sum of the card value shown? What is, use the counting on method to provide a number line to justify your answer. We're going to use this number line here. My first card drawn is a 5. So, what do I start? And which way am I going? Left or right?
Right.
Right. I'm going right. So, I'm going to go 1, 2, 3, 4, 5. And I stop at 5. My second card drawn is a -5. Where do I start? 5. That's where I left off. And which way am I going? Right or left?
Left.
Left. 5. 1, 2, 3, 4, 5. I'm back at 0. My third card drawn is a -4. I'm starting at?
0.
Which way am I going?
Left.
Left. 1, 2, 3, 4. I end here. My last card drawn is an 8. I'm starting at -4 where I left off. Someone please tell me, looking at that question, A, what is the final position of the number line? Where do I land?
4.
I land at 4, right. So I start here and I go 1, 2, 3, 4, 5, 6, 7, 8. I'm back at 4. So for A, the answer would be 4. The final position on the number line, 4. Yep. No. Oh, you don't have to draw that. Just give me the answer 4 here. Well, you can. It'll help you if you need to. All right, B says, what card or combination of cards would I need to get back to 0? I'm on 4.
4.
I would need a -4. Yes.
Yeah, -4.
-4, right?
That's what I mean.
Or I could draw 2 times and I can pick a -1 and a -3.
Mm.
So either one, I could draw once and get a -4, or I could draw twice and get a -1 and a -3, right it. I'm answering the question to B. It says, what card or combination of cards would you need to get back to 0? 4. Yes. I can. Yep. I definitely can. All right, the next question says, use the number line to answer each of the following questions. A, how far is 7 from 0 and in which direction? 7 units to the Right.
Wait, what? Oh, for 0? Oh, I didn't know.
0, 7 to the right. This is right, this is left. Write it. 7 units to the right.
You said 8, what?
7 units to the right. B says, what is the opposite of 7?
-7.
Write it. -7. Correct. Real nice. Okay, next question says, how far is -7 from 0 and in what direction?
7 to the right.
7 to the
Left.
left. Thank you. 7 units to the left.
Keep
Yes.
forgetting to start from 0.
Write it.
Wait, -7 to the left.
7 to the
7 to the left.
yep. All right. So if we flip it and we look at D, it says thinking back to our previous work, explain how would you use the counting on method to represent the following. Oh wait. While playing the integer game, the first card selected is 7. The second card selected is -7. How would I do this? I will start at what?
0.
And then I,
Go to 7.
which way?
Right.
Write 7 and then
And then go back, left.
left 7 and then I'm back at 0.
Mhm.
So again, start at 0.
Because -7 is left, so +7 is right.
Start at 0. Move 7 right.
Wait, right start at 0?
You start at 0 first. You move 7 right. Then you move 7 left. Back at 0. What about E? E says, what does this tell us about the sum of 7 and the opposite of -7?
Wait, so right one of the little, what's the name?
Huh?
Right one of the -2?
What do you mean?
Oh,
Write this right here. Look at E. What does this tell us about the sum of 7 and its opposite, -7?
Move right 7 times. And then move back.
What does it tell us?
Yeah.
Huh?
It's the same
Same distance.
Yes, but it also tells us that it equals
Oh, 0.
0. Yes. So it also tells us that 7 plus a -7 equals 0. Notice that I put that -7 in parentheses because if I didn't, this is how it would look.
True.
Which down looks really, really silly. So we would never write it like that. We have to put the negative number in parentheses. So what it tells us about the 7 and its opposite is that 7, the positive 7 plus a -7 equals a 0. That's why when we do some of our things and I say they cancel out because they equal 0. Look at the curved arrows you drew in 7 and -7. These right here. What relationship exists between these two arrows that will support your claim of 7 and -7? So if I had 7 loops here, what is the relationship between these two?
They're both
The same distance.
zeros.
Exactly.
Same distance.
They are the same distance, just opposite directions.
Hey,
They both are the same distance from 0, just opposite directions. That is correct.
Oh.
All right, G says, do you think this will hold true for the sum of any number and its opposite?
yeah.
I believe so too. Any number and its opposite will equal 0. So yes, even, yes, even the biggest number.
The biggest number
Even
is
infinity is
times infinity and it goes over.
Exactly. Now you guys, was that a hard lesson?
Yes.
Not at all. The lesson was very easy. So the next thing you're going to do is your exit ticket, and your exit ticket is just the same thing that we just did. Both of those get turned in today, and then you'll have your homework. I'm passing it out now.
I said this and the exit.
Yes, both of those. And those that are virtually, you will turn in that, you will put all your answers for the problem set, which comes right after the lesson that we just did, and you will turn that in on the Google Docs. See you all tomorrow.
But you